On the right-hand side, you can see the graph that shows how much global temperatures have continued to increase over a period of time. We also need to recognize that if we are going to be sustaining this one planet that we've got for a population that may exceed to 11 billion by 2100, then we need to think about the implications for that, not wait till 2100, but start thinking about the implications for that right now. And again, you can see the footprint that humanity is causing on the planet, and how we are already living beyond the means, the ecological means, beyond the sufficiency of this one planet. And without going into detail here, and South Africans would be very familiar with the same context that we have here in Australia as well. We are very much a resource-rich country, and you can see the impact that 1 kilogram of gold leaves behind in terms of the disruption, biodiversity loss, but also ecological loss, and so on. And you can see all the figures on the left-hand side, the 6 of them, that goes through the particularly things like freshwater use, marine life, as well as forest loss. So moving along, as I said, we are living well beyond the means of our planet, and we know already that from about 1970, we have crossed the limit of the sufficiency of the one planet, and we know that at least here in the Australian context, we go through this overshoot day around the middle of the year, and we need to start thinking about how the whole world is going to be able to live in a just manner, and there's equity across the world. It's not possible for us to continue to live in the same lifestyles, for instance, that Australians do, which is looking for about 7 planets, and that's just simply not possible. And this is the basis in which we start talking about the circular economy. So the circular economy, unlike the linear economy, which you can see on the left-hand side, is where we have today taken resources from the planet. We haven't thought very much about where these resources end up, mostly in the form of waste. There's a little bit of work going on in terms of how some of that waste could be reused. We call that the recycling economy, but truly in a circular economy, there is no such thing as waste. We continue to use resources over and over and over again. And there are other ways in which that could be expressed. For instance, we've got the technical cycles and the biological cycles, as you can see in the diagram in the middle. And then you've also got in the bottom right-hand corner how you can try and think about it from a full design perspective as well. So we are truly circular when we don't need to mine for virgin materials anymore. The most common definition, or the most common understanding or popular understanding, like the Brundtland definition of sustainability, is the one by the Ellen MacArthur Foundation called the butterfly diagram, which demonstrates on the one side, on the left-hand side in the green, the biological cycle, and on the right-hand side, the chemical cycle. So as it is in nature, biological cycles can be continuously used, and it allows the planet to regenerate. Whereas with the technical cycle, that is not possible over a short period of time. You're looking for hundreds and hundreds of years for technical cycles to be able to regenerate on the planet. And that, again, from the perspective of the fact that we have already overshot our use of resources on the planet, and the fact that we have got an increasing population, this is simply just not possible in the near future. So without going into the detail of the definitions, As you can see, I mean, there are 4 definitions that I have provided to you here, one by the Ellen MacArthur Foundation, one by the US EPA, the European Commission, and the Brundtland definition, all slightly different in terms of its take. But what is really critical, I think, to understand is, unlike sustainability, where the environmental movement drove the solutions associated with sustainability, and the economic sort of came in much later, and the social even much later than that. In the case of the circular economy, it's unashamedly looking at how we can bring allow the planet to regenerate and bring in solutions that also provides economic incentives, and economy is the basis for making these decisions. So what are some of the themes that we need to consider when we start talking about the circular economy? So some of these themes are things like, it's important to think about the design perspective, because we need systems to create systems so that we don't have waste anymore. And that will allow then the earth to regenerate, particularly if we start thinking about more of bio-based materials and bio-based products. We need to start thinking about how we optimize resources, how we can make things more efficient, what are these inputs, where do we get these inputs, and where do these outputs actually end up? How do we maintain utility for systems? So the shifting from more of just the cost value into from the cost into the value of the product. And in all of this, how do we also cultivate a repair movement so that products can last much longer? And how do we ensure that we bring renewable energy into the mix? So from my perspective, the circular economy is actually a subset of sustainability. It sits very much as a part of sustainability within the economic lens of how can we reach triple bottom line sustainability. So going back to that point about the value chain and thinking along the lines of the value chain, it is really, really critical that we start thinking about not just any one particular aspect of this diagram here. So, thinking about, for instance, the design of products, and I mentioned about how can we make things last longer. So in order for things to be able to last longer, think about your phones or your laptops or anything that you might be buying. We have now moved into that linear economy where we buy things, and when they don't work, we throw things. In some countries, and certainly in Africa, countries of Asia, Latin America, the throwaway culture is not yet prevalent, but we are heading there. As people across the world want to try and live in the same lifestyle as Americans and Australians, where we are actually cultivating more of the throwaway culture. So we need to start thinking about, what do we use to make these products? How do we make them with more and more of the use of renewable energy? How, instead of owning products, can we start thinking about product as a service model? So thinking about ways in which Uber, for example, is a very good one of a service model where you don't own a car, but you want to be mobile. So you use Uber as a service to move from one place to another. In the same way, thinking about the use of products, think about how these products could be extended, lifetimes could be extended to reduce pollution, and so on. So now thinking about it from a built environment perspective, which is really the focus of my talk, how does that resonate within the built environment, and how do we look at buildings from that circular perspective? So there are a number of different definitions of what is a circular building, but really what a circular building does is it looks at how can we optimize resource throughout the life cycle of a building. So again, the design of the building becomes really, really critical. And as you can see on the right-hand side in the purple, the light blue and the blue, we really need to start thinking about materiality, and how do we use these materials for as long as possible. So things like, once buildings are built, how do we ensure that these buildings stay for much longer? How do we change the function of buildings? And how do we retain these buildings to be use different functions over a period of time? How can buildings actually become material banks? So how do we use spaces more efficiently within buildings? And how do we ensure that if these buildings become material banks in the future, how can these buildings equally be deconstructed, not just be constructed? And what are the tools that can help us along the journey to get there? So things like material passports or digital passports within buildings. So what are those principles that we use in the built environment? Essentially, there are three. And it doesn't matter whether it is actually the built environment or any other thing that we're thinking about from a circular perspective, because we want to conserve resources, increase efficiency as much as possible. We want to design such that we eliminate waste completely and we retain the value as much as we can. And so there are different ways in which this can be done. For instance, you minimize the use of virgin materials, you use more of the materials that are already in the marketplace. You try and ensure that the types of materials that you use in buildings are bio-based, so bamboo, mud brick, clay bricks. These are some of the materials that can be used. How do we ensure that they remain in the building for a much longer period of time? And how do we ensure that we don't demolish buildings, but we actually deconstruct buildings? Because if we demolish it, you're actually crushing it, and you're not able to reuse those materials again. So how do we manage construction waste? And peppered within all of this are things associated with policy, regulation, standards, and certification. So when we talk about circularity, we also, in that context of circularity and sustainability, we often also talk about net zero. And so what does net zero actually mean in the context of the built environment? Without going into too much detail, I want you to focus on the left-hand side, which is looking at whole life carbon. And whole life carbon includes the operational carbon as well as the embodied carbon. And in order to be able to reduce this embodied carbon, on the right-hand side, extreme right-hand side of the graph, of this graph here, you want to try and reduce the amount of embodied carbon in the building. And that's what we're trying to do in this line that is looking below here where you've got reduced embodied carbon. And you want to try and compensate as much as possible in terms of the operational carbon by other ways, such as using renewable energy in buildings or creating net positive value in buildings as much as possible. So you actually move, and this is really where we are at now, building codes and standards have moved into energy efficiency, but moving beyond energy efficiency into nearly net zero, so that if you cannot produce that energy on site, then you can actually draw that energy in from other places. But if you're producing more energy on site, you can actually sell that off or give it to other places. So the sum game is really getting to net zero in terms of both operational carbon as well as embodied carbon. And things like offsets, etc., also come into the picture. It's also important to think about who are the different players when we talk about the built environment. And in the work that I have been doing with the Materials Hub of the Global Alliance of Buildings and Construction, we have been looking at a range of different players, RMIT University, so myself, the Ministry of Environment Finland, hosted by United Nations Environment Programme. We've also got NGOs such as Habitat for Humanity involved. And what we have been doing is looking at the work that we have been doing since 2015 to 22 in the One Planet Network's Sustainable Buildings and Construction Program, where we were the first global agency that looked at circularity in the buildings and construction sector. We developed a number of reports. We mapped the state of play against the Sustainable Development Goals. And you can see on the right-hand side that we looked at things like the regulatory and the policy incentives who are the commissioning agents that need to get involved, what is the role of the logistics operators, so the people that transport and procure goods and services, and how do we ensure that there is continuing education across all the parties involved, from planning, the people involved in the property market, the financing parties, as well as ensuring that the client is also well aware and puts circularity and sustainability central to their brief. The work that we have been doing in the circular built environment work has continued since 2023. In a minute, I'll talk about some of the activities that we have been doing, but essentially our role has been to try and increase awareness and buy-in. And we do this in a number of different ways. We do webinars, we run events at the World Circular Economy Forum, we make presentations at the Conference of Parties meeting, we have been working on building capacities, and particularly the work that I have been doing has been looking and being part of an academic and research institution. Building capacities is a very important aspect that I bring into the work that I do with the Global Alliance, as well as informing technical work, the policy work, and the market work. So on the right-hand side, you can see examples of some of the activities and some of the areas that we have been working in to date. Just very quickly, over the 24-25 period, we have been working very closely with some of the UN agencies, such as UNEP and UNOPS and UN Habitat, particularly UN Habitat that has been looking at affordable housing. We have been working very closely with the One Planet Network's Sustainable Procurement Program, because procurement is a very important aspect of the work that we do, and we recognize that. We've got a project that has been funded by BMZ in Germany that is looking specifically at materials in the Global South, and we have undertaken training looking particularly at India and now in Bangladesh, and we have led a number of events at various forums that you can see under activity number 4. I don't have a lot of time left, so I'm going to just focus on a couple of things and leave it there and perhaps pick up some more during the question and answer session. But I just wanted to very quickly mention from a global policy perspective, we have had a very close role with the Buildings Breakthrough. So the Buildings Breakthrough agenda actually came up at COP26 in Glasgow, where the role of the built environment was recognized as being very critical to decarbonize. 45 countries agreed to take part and put their mandate. Unfortunately, Australia is not a part of it, and neither is South Africa. But Australia may end up being part of the official set of countries that have actually endorsed the whole life cycle recommendations, which I'll talk about in a minute. It is led by France and Morocco, so it was officially launched at COP28. Supported by 29 countries, and there are 5 priority actions, with the last one for coordination. So we're looking at work across standards and certification, demand creation, finance and investment, research and deployment, capacity and skills. You can actually take they've provided the QR code here. So our work in the whole 10 life cycle recommendations has been particularly linked to the last 3 on circularity. So recommendation number 8, prioritizing retrofitting, looks at how we can improve circularity in buildings and construction. 9 is all about the use of materials and how do we ensure that we shy away from the use of virgin materials. And the last one is looking at the importance of design. My time is up, so I think I'll leave it here. Thank you very much for your time. And I'll stop sharing.
Thank you very much for sticking to your time. I think I'm going to allow 1 or 2 questions now to Prof. Usha, because I don't know if you want to stay online for the rest of the session or whether you want to sign off since it is evening there on your side, Usha.
I'm happy to stay if you need me to, but I'm happy to take questions now as well.
Okay, let's open the floor for questions now. Then we can release her, that she doesn't have to stay on the entire evening there. Any hands? That was very clear and very insightful. It doesn't seem like there's any questions. There's one hand. Yes, sir. Please just use one of the mics, otherwise she's not going to hear you. Thank you.
Hi there, my name's Roland Thompson. I studied a long time ago at Strathclyde University where they were developing building energy management systems as part of energy efficiency. How much work is going on in that, what you would call AI management of buildings in these projects that you're talking about?
There is a big gap between what some of the developing countries are doing and the emerging economies are doing, and there's a big gap in countries that are still looking at the use of firewood to make building materials. So there's the scale is very wide. In terms of your question about the use of AI, lots of things happening, particularly around building monitoring systems, and that is why energy efficiency, I think, is, we have done what we can in terms of energy efficiency, in terms of use of photovoltaics for renewables in buildings, and to some extent even with water efficiency. And this is why the discussion and the narrative, particularly in the global north, is shifting very much to how can we reduce embodied carbon in buildings. So we have done what we can in terms of operational energy and operational energy use, but what can we do in terms of the embodied carbon in buildings? And that is why it is really important to start thinking about using building materials, using spaces that are already there. How can we, reuse buildings and adapt buildings for reuse? So that's the issue in the global north. In the global south, and I'll give you a good example from Bangladesh, where the government, because the country is relying on importing fuels, there is some gas in the country, but as part of its nationally determined contributions, the government of Bangladesh has got a policy where they have said that they don't want to use clay bricks for two reasons. One, of the amount of energy that it uses to produce clay bricks, but the other reason is also topsoil loss. But what the country has done is they have moved into the direction of what they're calling as eco-bricks. But these eco-bricks are actually using clinker that's imported into the country. So the embodied content is very high. So one way out to try and reduce embodied carbon is to use local building materials. And a lot of the local building materials that I use, such as mud bricks or hemp or bamboo or timber, these are not treated. So these bio-based materials are not being used with modern technology. So it's really important to therefore build capacities so that they can use these bio-based building materials, but with 21st century thinking. And there is a lot of role in here for things like AI to play, particularly for heating and cooling buildings. So I hope that answers your question.
Thank you very much, Prof. Ushal, and thank you for your time and for a very insightful presentation. I think I'm going to move on to the next presenter. Since the remaining three presenters are all in the room, I'm going to take one presenter after each other, and then we can take questions at the end. So if you can please just make a note if you have questions and wait until the end, that we don't run too much into lunchtime. The next presenter I would like to call to the podium then is Dr. Mark Napier for his presentation on creating more resilient, livable human settlements through a circular economy. Mark, thank you. The down arrow. Is what we use.
Good morning, everybody, and thank you very much for the invitation to speak. You'll see that I'm presenting on behalf of a group of authors, and who I'll introduce you to as we go. I'm part of a research group called Housing and Urban Studies in the CSIR Smart Places, and we also run an online knowledge platform called the Urban Knowledge Exchange, which has got a lot of information on it. So some of the references I'll give are available there. And I've also got some references to these papers as well. Yes, so our paper, Creating More Resilient, Livable Human Settlements Through a Circular Economy. This was a paper that came out this year that was part of a much broader project that I'll also mention. You'll see there's many authors. I'm author number 7 of 8, and that gives me a minority viewer position where I'm allowed to critique our own paper. So some of the things that I'll be saying is actually thinking of some of the debates we had during writing the paper, and also some of the thoughts after writing the paper. So we'll take this as a collegial atmosphere of debate. And so those are the sections we'll go through, just looking at the circular economy, which I think Professor Usha has very wonderfully introduced, so I won't have to say much about that. But we're talking in a human settlements context, and we're talking about circular economy interventions. And even there was a session that I went to before this, which was chaired by Dr. Coralie, and that had a lot of the possible solutions and interventions and actually ideas that could be taken forward. So I think there's a lot of knowledge already in this group. So those are the authors. I'm devoting this paper to Dr. Jeremy Gifford. He passed away at the end of August. He was our first author, and some of the debates and thoughts actually came out of the debates that we had as a group working on this paper. And he was a great proponent, also an architect. And then the rest of the group, you can see there's a modeling section in the group that did some of the modeling, and then Linda Godfrey as the kind of the patron of a lot of this work within the CSIR. So I'm going to try and present on behalf. I'm more of an urbanist, in case I'm later accused of being a wolf in sheep's clothing, or a sheep in wolf clothing. And so I come more from that urban housing, human development perspective, which I think gives us some of the debate that we had while we were looking at this. This is part of a much bigger project that looked at circular economy in mining, agriculture, manufacturing, human settlements, which we looked at, mobility, which is the transport side, and energy and water. And so we were focusing more on the human settlement side, and this has been at least a 3-year process of coming to where we are at the moment. So why this topic? We've seen already, and we've seen the numbers in this and other sessions around human settlements being responsible for a lot and most of resource use and emissions globally. I think Peter de Jager had some very good figures in the previous session. And we as South Africa, as a country, we face particular challenges, especially linked to the urban sprawl, the physical form and the spatial form of our cities. Infrastructure that's not terribly efficient. The World Bank's done a lot of studies about the business efficiency of South African cities and African cities compared to the other parts of the world, and therefore high carbon emissions. I draw your attention, I don't know if there's a little... I draw your attention to this quote that we had in our paper, 3% of the Earth's land surface being urban, but 75% of the world's natural resources sort of supporting that 3%. This is actually very good news, because if the people are concentrated into 3% of the space, it should be even less than that, then you are able to manage a lot of this and come up with more efficient urban systems. We'd be worried if it was more than 3%, but obviously where the people are is normally where a lot of the consumption is. So it's a bit of a truism, But in fact, what we want is urban areas that are efficient and well designed and are looking to the future. Currently, they're not. But when you first look at these numbers, it sounds like it's a bad thing, but it's actually a lot of human development goes better in cities, and that's a long-running debate. And there's obviously a lot of different aspects to this. So what we were doing in this paper is exploring how circular economy principles and interventions can make a difference in human settlements, at least within this country. I won't go through the definitions again, but the linear versus the circular economy. I am going to come back and challenge a little bit of how practical that is, but it's certainly, that is the base and that is the thinking that we were working off. And I think our first speaker this morning already has really done it's a wonderful set of definitions and depth in the definitions that were presented just now. Then, this is an ICLEI diagram of the kind of principles that would go into a circular city and the actions to achieve that. And again, I won't go through that in too much detail, but there's also this impetus and a lot of work we've done on smart cities. So there's a great aspiration towards smart cities, smart African cities, technology solutions, and there is an overlap between the thinking, but they don't always pull in the same direction. The smart cities movement and aspiration doesn't always pull in the same direction as the circular economy type of, or the circular city type of thinking. And we've done a lot of work in both areas, and I think we need to be pulling these things together around, and also more productive cities, inclusive cities, and we're all trying to achieve various things. They don't always add up, but we need to be speaking to each other about what is a functional, equitable, just urban system within a very rapidly urbanizing continent. And that's at the base of a lot of what we're talking about here. Right, so just to briefly, in one slide, I've written 30 years of papers on the South African context. Now I've got one slide. But the challenges of the human settlement context in South Africa, our current development path, although there's a lot of policy and work and incentives to reverse this, but the current development path is quite low density with pockets of high density. It's often correlated with poverty as well. There's this settlement pattern of standalone housing in a more suburban context, and people, especially poorer people, pushed out onto the periphery of cities with very long commuting distances and times. So that's the commuting, the transport costs, the time costs, your infrastructure that has to be extended very far. And then ironically, the wealthy also want to be far out, to be away from the urban areas, which also generates a similar kind of thing, but with different land values and underlying property markets and reasons for development. So that puts a lot of strain on our infrastructure. If there's no change, then that's likely to carry on. But we need to look at these much more systemic and fundamental changes in both the urban form and in the incentives to change the urban form, but also in the infrastructure and the technologies that will help us build more functional and resilient and less wasteful settlements and cities. So what we did first is we just looked at some of the typical, and I think there was a slide in the previous presentation as well, but these were some of the typical human settlement related interventions that you can look at to make a difference. So we started off with 17 in the group that we were working. The ones with little asterisks are the ones that we then chose to take further. So things like the 15-minute neighborhood, design for disassembly, etc. You can read them on the screen. There's a lot of different possible circular economy interventions that can make a difference at different scales. The last one, hadn't come across virtualization. That's a kind of a fancy word for just having sensors on site that allow you to monitor what's going on without having to always be there on site. But it's also sort of the smart sensors and digitalization side of things, if I'm understanding it correctly. And you can see roof garden. So Jeremy, the first author, the late Jeremy Gibbard, he, as an architect, has tried to design and build and has built roof gardens in different parts of the world. The first problem as an architect is that your client says, but your roof is leaking. It's incredibly difficult, especially in a climate where there is torrential rain and even not just drizzle, but anything beyond drizzle, and also very harsh sunlight. And then what you're basically doing is you're putting a swimming pool on the top of every building. So there were quite a few non-starters that we came up with, both from our experience, but we also chose ones which we thought could work and also that we had data for, and that we could go into this modeling exercise that I'll mention now. So then the next stage, I won't go through this in detail, was just to have a survey and a set of focus groups with South African professionals and officials around who was familiar with some of these interventions, what did people think about which ones would work, which ones did people think that we had started in the country. You'll see on that last line, the least familiar in people's minds locally was what is meant by loose fit, long life design. Equipment libraries were fairly unfamiliar to people. Design for disassembly was also not that familiar. So, there's a lot of these ideas that are well developed in certain societies, which are not that common here. And that's a good starting point, I think, for understanding where the opportunities are. Right, so then what we did is we took those 5 and we did a whole modeling exercise, the 15-minute city, urban agriculture, composting, grey water, rainwater use, and reuse of building waste for reconstruction. And the modeling group that was in the author group used a lot of data, especially from the city of Johannesburg, to do an exercise. And there's a whole appendix to this paper which unpacks each of these and how they were modeled. And now bear in mind, this is a sort of back of an envelope. Well, the modelers won't like me to say that, but it is a back of the envelope exercise to see what scale of difference could these make. So in this 15-minute neighborhood scenario, it was percentage of households within a 15-minute walking accessibility to points of interest. And because of the data, we concentrated on schools, from preschools to secondary schools, clinics and offices within the city. Urban agriculture, again, we took the Gauteng province and the city of Joburg as an example in a case study. On-site composting, which is using food waste and other waste on the site. And grey water, I think it's all self-explanatory. And then reuse of construction waste, which was more done in the modeling terms, in terms of if there was a large development that was going to be happening in a more formal context, when a current neighborhood was, for instance, being removed in order to put up a big complex, a big commercial complex. So we did it more in that kind of scenario, in terms of the modeling. I'm sorry, I keep going backwards. It's counterintuitive to be going down. Right, so very quickly, the findings which are written up. Again, this was taken through to 2042, is that you could make a difference to the number of households in Gauteng, or in Joburg actually, was 1.84 million households. You would make a bit of it, at the moment, if the spatial development framework of the city of Johannesburg, which is quite progressive, was actually then put into practice, which has strong sort of elements of densification and provision of different facilities. You could make a difference in the lives of 100,000 households, but if you extended that to a 30-minute neighborhood, then it's 300,000 households, which is significant. There's a bit of change there. What I would argue from some of our previous research is that a lot of township neighborhoods, historical townships as we would refer to them, is already walkable. I mean, every third household that we surveyed in Mamelodi is a home-based enterprises. You've got spaza shops, you've got traditional healers, you've got hair salons, you've got car mechanics. So when we talk about the formal walkable city, we talk about land use and official zoning, which definitely has to change. But you talk informally, there's a lot of facilities embedded within communities already. Urban agriculture, we could feed 20% of Gauteng's population using all the open space. The downside is you'd have to use a lot of your grasslands and forest lands to do that. So where on the one side you might be able to produce 20% within a very urban space, you've got to look at how you do that. All of these I could expand further, but let me just refer you to the appendix and to the paper. The composting, that's a no-brainer. You can definitely do a lot by composting within households and within businesses and make a difference there. Grey water, rainwater, again, with the kind of climate around the country, it's different in different places, but there could be a massive use of that, much more than there is at the moment. When I talked about this last week to a set of Free State University students, there was an immediate response as no, but we can't use grey water. And then I also spoke to somebody in Cape Town who I'll mention just now. There are issues when we talk about grey water, we mean from sinks and baths and showers and things. But there's definitely, in different parts of the country, different attitudes to the reuse of wastewater, or grey water especially. There are building materials, I think that can be done, but a lot of our buildings are reused. Anyway, let me start to just finish off, but that would be just a typical sort of plot-based set of recycling and circularity. But as people like Coralie will tell you, some of these things are done more efficiently at a level up. The groups of households being able to do this in more than just at one household level, and also then using some of the surrounding open spaces. Right, so now coming to beyond the paper, the critique in my mind. Well, this was in my mind, and then I put in a very clever prompt to ChatGPT, and then ChatGPT gave me much more eloquent ways of saying this. So circular economy thinking can be seen as techno-optimistic. If we put this technology in this technology solution, it will make all this difference. And in our modeling, because it was on paper, we had to be optimistic about the kinds of scale of change it could make. So it was an exercise. It didn't mean we were saying this could be done or how difficult or easy or it would be to do it. So I think that's one thing. It can fall into this displacement and scale challenges. If you make advances in one sort of spatial area, you might be displacing that to another area, and then the net gain may not be quite what you're looking for. I think we're all familiar with this kind of critique. Sociocultural dimensions, I mentioned, for instance, the use of grey water. Certainly composting toilets is acceptable in certain parts of the country and not in other parts. So again, those sociocultural dimensions are very important to consider. And then underestimating the political economy is the existing vested interests. I mean, try and change the cement industry quickly, or the clay brick industry, fired brick industry. Those, I mean, we were talking about this in 1985 when I was a student. Clay bricks had a big competition, and I refused to be part of it as a radical student because we were using clay bricks, and I made a concrete block project. And then because I was using cement, so which is just as bad now. But you know, these vested interests are very, very strong, and the critical paths and the path dependency actually is very crucial to understand. Then lastly, what I did was, when I was thinking about this critique, I phoned a friend, which is what some people do. So there's a woman, Adele Hoskin, who works for the Climate Adaptation and Resilience Program in Cape Town. Now, she's been in Cities Alliance, which has looked at urbanization in Africa for decades, but now she's working in a circular economy type of organization. So she had some amazing ideas. When I sat next to Linda last evening, Linda Godfrey's got many of the same ideas, but basically, if you're moving from modeling to impact, from modeling to implementation, we really need to think about how do we validate these models? How do we sense check them? What we've done on paper? How do we bring people in as stakeholders? The co-creation, which we've heard about in some of the projects that we've heard about in the last day or two, is involving the stakeholders in that implementation. So you don't get right to the end of the project with an informal settlement grey water project where people use their grey water into an open channel down to a tree. And as soon as you start building it, the community, this is what happened in Cape Town, says, no, we can't do that. You start that much earlier. And I'm just using this as an example. I know it's contested, but these are some of the considerations. Living labs, where again you put the stakeholders together to actually experiment. And then especially understanding scaling. So we tend to look at horizontal scale, but you can also look at the vertical scale either physically or in terms of densities. So vertical urban agriculture, not just horizontal agriculture. And I think that's it. I'm not going to go through, we had recommendations. They're not too important, but basically let's look at all of these things in more detail. We think it can make a difference, to human settlements in the country. And then we do pose the question, informal settlements are seen as visible examples of where the challenges are, but actually it's often about the underlying rights to land and the right to adequate housing that can keep on driving this pattern. I'm going to just end with that one. We just started or launched a G-STIC product, which is an online repository of alternative technologies. So a lot of these things you'll find on that site. It's brand new, so there's not a lot there. So if you have any circular economy technologies, please upload them on the site. Thank you.
Thank you very much, Mark, for a very informative presentation. Next in line, we have Dr. Tahira Goga, and I'm going to allow her to stand there where she is, simply because we want to see her. She's a bit disadvantaged in terms of height, so let me just hand the...
Sorry, just receiving a fair bit of instructions from my panelist. There we go. It's just gone afternoon, so good afternoon to everyone. My name is Tahira Goga. I'm a researcher stroke engineer with the CSIR. And together with my colleague, Dr. Valentina Russo, we've prepared this presentation. And the intention behind it is to basically investigate how industrial ecology tools and concepts can be used to future-proof not just cities, but sectors and countries. So I've chosen to start off with this particular slide, and what you'd see in front of you is two global maps. Quite a busy slide, but what I wanted to point out was two aspects in particular. If you contrast the map in 1990 to the one in 2018, you would notice that the green and turquoise patches are actually sort of transitioning and shifting to yellow and brown patches. And this speaks to the increase in percentage of urban dwellings, basically. The other thing I think that is noteworthy in for these particular maps is the increased proliferation of the blue dots. And this speaks to increased smaller cities of population 1 to 5 million. And the modeling tells us that this trend and trajectory is going to continue. As the text says, now half of the world's population actually lives in cities, and this will reach 60% by 2030, and is expected to actually reach 75% by 2050. So I've listed a few drivers and barriers to sustainable urbanization. I'm not going to go through all of them, but I think it's important, first of all, to mention that sometimes the driver and barrier can actually just be two different sides of the same coin. So an example of this you'd see in orange, I've listed high costs and financing gaps. We do know that the setting up of some sustainable urbanization infrastructure actually requires some significant investment upfront. However, we are seeing more and more green investments, so whether these are green bonds and other financing instruments. Traditionally, they've been financing renewable energy, grids, green buildings. The most recent one that I've come across is actually the Renew program by Nedbank, and this is financing waste entrepreneurs, so something to look out for. perhaps just, I think, one more that I wanted to mention on this slide, the aspect of social inequality and the fact that as we are replacing our aging infrastructure, what we need to keep upfront in mind is the fact that there needs to be equitable access for all to housing, transport, infrastructure, etc. So what exactly is industrial ecology? And I know someone asked me this yesterday. I don't know whether I did the definition justice. But the International Society for Industrial Ecology gives a very, well, sort of straightforward definition. It's basically the study of relationships between society, the economy, and the natural environment that we reside in. So some of the concepts that you may have come across or may be familiar with, I'm just going to speak to a couple. So eco-efficiency and eco-design. This is where you have certain product and process design, which looks at decreasing your environmental footprint, but then on the other hand, you also want to maintain a strong business case. In terms of tools, and we're actually going to look into some case studies that use these tools in the next couple of slides. However, just very quickly, material flow analysis, quantification of flows and stocks within a system, life cycle assessment, whether this is environmental or socioeconomic. This goes a step further than material flow analysis, and it basically tries to predict the impact of a product or service. And then in the policy space, I've just put EPR, and this is exactly what the sort of title says. It's where the producer has this extended or additional responsibility to actually responsibly manage the end of life of its products. And that actually ties in quite nicely to eco-design. So in terms of a few case studies, this is a very brief slide just to show the sort of evolution of tools. So on the one side, you will see a diagram that shows the urban metabolism of Brussels in the early 1970s. Quite a busy slide, but quite a lot on there. And then moving along to quite recently, some might argue that this is a more sort of sleeker version of the previous graph. And this shows the waste sector in a particular city in the States, looking at the origins of the waste, looking at where it goes to. Perhaps important to mention at this stage is that this is a result of a material flow analysis. It's termed a Sankey diagram, and what a Sankey diagram is, the width of an arrow or a flow is indicative of the quantity of the flow flowing through that particular stream. Sorry, lots of flows there. This is a sort of what came out from a study related to Cape Town, and this is a sort of comparative graph that came quite at the end of it. What is important to note here is, despite Cape Town being a harbor city, it contrasts actually in terms of the sort of 2 to 3, in the order of 2 to 3% difference between Cape Town and Paris, and you can see this in the imports and exports. And then if we look at DMC, you can see that the contrast is actually even greater. However, that's Cape Town. But what I wanted to mention on this particular segment is that a city is not necessarily representative of other cities within the country. It's not necessarily representative of the country and other surrounding regions. And I've just put up a few indicators here. You can see this in the Gini coefficient, for example, and also in the literacy rate. Okay, so moving along now from city and actually expanding it to sectors. The two diagrams in front of you are a representation of the South African plastic sector, and where we try to model plastic flows. So first of all, you would notice that there's two different perspectives that are being shown. The one at the bottom is more a sort of overall perspective, looking at, for example, from local polymer production, use, disposal, recycling, and it carries on. Whereas the one that's higher up actually sort of shines a spotlight more on the end of life. So what happens after demand, consumption, disposal, etc. In terms of the highlights of these two diagrams in particular is the fact that it includes circularity, and in this case, it's in the form of mechanical recycling. Additionally, it also acknowledges, mentions, states the fact that we do have informal disposal methods, we do have informal collection and informal sorting. And this is important in developing contexts. And then lastly, why are these interesting and informative? It's the fact that it does highlight areas of concern, and it does this by showing, I mean, you can see the large flows. So for example, the diagram at the bottom, the large orange flow, 954 kilotons. What this shows is that just over 50% of plastics produced in 2018 were used and disposed in a single year. So going from sort of modeling what is currently happening to forecasting. So you ask the question, you ask what if? What if, for example, the plastic sector, we implement EPR? What if we combine strategies? What impact would that have on certain indicators? And you can see here, for example, on the indicator of plastic pollution, 33% decrease, and then if you combine strategies, you're going to end up with a predicted 63% decrease in 2040. And then you can extend these, so instead of just looking at plastic pollution, you can look at other indicators, so social indicator, jobs, employment, always critical and important in developing contexts. Looking at global warming potential and climate change as well. So just to summarize what's on the slide, and I think I've mentioned this, second point is important, the fact that you can actually predict and model individual scenarios and strategies, whether these are circular or decarbonization, but you can also show what the combination is capable of. So moving from the plastic sector to green hydrogen, this is one of the findings from an environmental life cycle assessment. I just want everyone to focus on the text at the bottom, and I think that summarizes it quite well. The fact that green ammonia, green hydrogen production by itself, according to the model and the predictions, will actually meet the thresholds for certification. However, when you add in the sort of transport, distribution, and use, these may only meet some thresholds, and therefore there are quite significant emissions in the transport and distribution phase, and I think this is noteworthy going forward. So moving from the environmental life cycle assessment now to the social and the socio-economic life cycle assessment. This is just a snapshot of the study that was done for Saldanha Bay. Note that the complete study is 128 pages, so there's not a lot of text here, but I mean, it is quite lengthy. Speaking to skills and jobs in particular, the fact that the evidence showed, so this is talking about green hydrogen, renewable energy, the evidence shows that there are existing initiatives, programs, educational endeavors, etc. However, there is no mention of a role for TVET colleges within that sort of space. On the jobs aspect, quite a few numbers over there, but the one I wanted to highlight was the link between jobs and skills. The fact that in your sort of temporary commissioning phase, your construction and installation, that's where we foresee that the majority would be low-skilled employees, whereas in the sort of maintenance phase and operations, we predict that this is where people would require, a higher skill set, basically, and additional qualifications. And then moving along to a few more material topics, not going to go through all of them, but perhaps the one to mention is the one on investments, the fact that the sector is predicted as having a benefit to the country's GDP. However, one of the resources did show that the IDZ is currently only performing at just under 20%. Last sector slide, so moving on, so we started with plastics, went to green hydrogen, and now we're on textiles. This is a project that is currently in progress. We're looking at textiles, but in particular cotton clothing. There's various components, as you can see, LCA, MFA, consumer research, waste research. In phase one, what we want to look at is a couple of different interventions, and this should speak to, I think, everyone who enjoys their shopping. The fact that what would happen if you have a longer use of your particular clothing item. I'm sure some of you are familiar with certain store buyback initiatives where you can bring your clothes back and you get a discount perhaps on your next purchase. what impact would that have? And then in phase 2, the two sort of strategies that we would like to look at, the one is on localization, and the other one is replacement of alternative materials. And then sort of related to this is the Intex project. This was, I think phase 1 was concluded, and I've listed the activities there. Notable is that it included South Africa, but also other countries like Kenya, Tunisia, Indonesia, and India. And phase 2 is currently continuing. So we've done a little bit on cities, a bit more on sectors, and I just want to highlight how industrial ecology plays a role for national circularity opportunities. So really quickly, there was a UN NDC toolbox that was developed, and the intention of this was actually to identify the biggest and greatest opportunities for material circularity, and this is contributing towards the reduction of GHG emissions. Surprisingly, at least for me, the most promising sector was actually, came out as the building construction and civil engineering construction. 8 circular economy interventions were identified. The model said that it has the capacity and capability to actually reduce current emissions by half. And then there are also some socioeconomic and adaptation co-benefits. So I think the previous speaker has done a brilliant and fantastic job, actually, on presenting the report. I think what I wanted to mention on this is that my colleague has actually graphically represented some of the circular economy initiatives, and she's mapped it according to how widely adopted a particular initiative can be, and then in terms of its readiness state, and how it's implemented, or how it could be implemented. So last slide, what is happening in South Africa as a whole, result of a material flow analysis undertaken by UCT and the University of Vienna. In terms of key findings, we can see that the economy is fairly linear, powered by fossil fuels in particular, really low stock or build-up of stock, basically, and this is comparative to other developing and developed countries. So as in terms of our roads and our buildings, relatively low stock of that. However, the good news is that there are pockets of circularity, and there is a significant amount of informal activity happening with respect to reuse and recycling. Some conclusion and key messages from my presentation, the fact that we know that there are a wide range of environmental risks that are prevalent in cities. I hope I've demonstrated that industrial ecology tools can actually be used to analyze this relationship between industrial processes, urban systems, but also taking unique socioeconomic aspects into account. And then lastly, the fact that these frameworks can be used at cities, but then they can go a step further. They can be used in sectors and countries to determine not just what is currently happening in terms of a reference case or a business as usual case, but actually do some sort of prospective modeling and forecasting by testing your circular economy interventions. And this is with the end objective of actually informing policy and legislation. Thank you very much.
Thank you very much, Tahira. Again, if you've got questions, please just hold them until after our next presenter. I would like to call Aubrey Muswema to the stage, and he is going to talk to us about actual circular bricks that's being made and demonstrated. Aubrey, the floor is yours. Down arrow takes it forward.
Morning. Actually, good afternoon, colleagues. It's a privilege to be here. I'm going to be talking on a project, a key bricks project that was funded through the Department of Science and Innovation. Just a very quick rundown on the table of contents. My first slide, problems, problems, problems everywhere we look. So glass and construction and demolition waste, there's very, very poor uptake in the building construction sector. Bottle-to-bottle recycling is not widespread throughout the country. We have 2 plants located in Johannesburg and 1 plant located in the Western Cape. That's 2 provinces in South Africa. What happens in the rest of the country, the rest of the 7 provinces? We have national backlogs approaching 2.6 million to 3 million households. We've got long construction times. So we partnered a 3-way partnership with the CSIR, an engineering company, and an SMME incubator. And the engineer had a technology that he wanted to introduce to market. And he approached the SMME incubator. And then we basically said to him, have you considered the circular economy potential on the technology? So the equipment on the right-hand side, the big green monster that you can see there, that's the heart of the project. The project was made up of 3 partners: the CSIR, who had overall oversight of the project. We had Keybricks, who developed the technology. And then we had Use It, who drove the SMME incubation. So where was the circular intervention that we proposed to the engineer? And this is not a critique for engineers, it's just we sometimes think in our silos. So we proposed to him that why don't we consider and tweak the machine and just see how we could demonstrate to design out waste. That was already factored into the project because in the design of the blocks fit together with interlocking surfaces, and virtually it was like putting together a jigsaw puzzle and you built your house. We also proposed that we incorporate glass and construction demolition waste. The technology that we utilized, due to the design of the block, and that was primarily due to the interlocking facets, was small scale, low tech, and had a very high ease of replication with some basic training for somebody off the street with no previous background in construction. The block mixture consisted of glass and construction demolition waste. So the sectors where we were going to have impact was in the manufacturing of materials, blocks and materials for construction, and human settlements. Some other benefits, jobs at different stages, direct and both indirect. So you'd collect your materials from communities. It could be done with informal sector as well, and you'd have a return to construction of not virgin material, but materials which could be incorporated into the block. Basic skills transfer in terms of how to utilize the machine, in terms of how to lay out the blocks, planning the layout of rooms on a structure. Those were opportunities on the project. And most of the equipment was actually mobile, so it could actually be deployed to illegal dumping hotspots where you have your high volumes of waste products. The build time, total build time, was 16 days. So you put in your foundation, your floating raft foundation, 4 days for that to cure, and then you put in your walls, and then you put in your roof. Altogether, we achieved a construction time of 16 days. Other benefits of the project? So we actually used the pavers on site. The bricks we used as pavers on site for pavers in pathways and route connectors, so as you see in the photograph. Another benefit was due to the fact that the interlocking block had two voids within it, you could then introduce rebar into each of the voids if you needed additional support or retaining strength. And that can be seen in the last photograph. So in terms of mix proportions, that's your mix proportions with your recovered crusher run forming the largest component. Other recovered proportions include recovered glass, recovered sand, and also recovered sand, I beg your pardon. So we've applied for funding to DST, and we were successful, and we received funding for a 3-year project to demonstrate the project. And I'm not going to spend too much time on this slide, but we had to endure a Dragon's Den sort of pitch, where we pitched the project to the DSI, and eventually we were informed that our pitch had been successful, and that we were awarded some funding to demonstrate the project. The total project duration is 3 years. We're in year 2 now, just coming to the end of year 2 of year 3. In terms of the project that we needed to demonstrate on, these are just some milestones on the project. There was some material, equipment that needed to be fabricated. For example, we had the pan mixer and some other equipment on site. We had to fabricate and we had to establish on site, including the Mark III prototype, which took into consideration the use of the construction demolition waste. Another one of our deliverables was an RDP housing structure, a 40 square meter RDP housing structure. And following that was gaining market access through sale of blocks, uptake into market, etc. So all those milestones were completed year 1, year 2, year 2. We're still in the process where we need to get certification. Who here knows anything about agreement? Oh dear, okay, I'm not going to ask you to elaborate. We'll leave it at that. So those are the next challenge, those are the next milestones that we need to hit. And another milestone was that we needed to demonstrate the project to various stakeholders, including municipalities, provincial government, national government entities, etc. I'm not going to spend too much time on this slide. It's just the equipment that we had on site, and that was also fabricated. Some of it was fabricated as well. Some of the smaller equipment as well. This is the 40 square meter RDP house that we built in 15, 16 days, plus minus about 15, 16 days. And we had a launch where we invited the DSTI to come through, and it was quite a big hoo-ha, and yeah, we're really grateful for the support from the DSTI. In terms of costing, we looked at some figures regarding RDP houses, and on a comparison of a square meter to a square meter of the key bricks block, RDP houses typically in the region of a plus minus about 600 Rand a square meter. Our block comes in at 300 Rand a square meter to build a square meter of wall, Oop. There we go. And that's just a breakdown of the total days per stage. We were very lucky in that there was some offtake on site. So the project was hosted at Hammersdale Waste Beneficiation Center in KwaZulu-Natal. And on site, they have a number of demonstration projects. And we were very lucky in the sense that Hammersdale received funding to construct a 2,000 square meter e-waste sorting facility that utilized about 11,000 blocks. So we had some offtake of the product into market. That's just an in-process photo of the construction of the e-waste facility, which was a collaboration between Use It, Iwasa, and of course the Key Bricks project. Total cost for the structure was about 4 million Rand, and the structure utilized 11,000 bricks. And that's the finished structure that we put together. Just an indication of some of our project indicators. So we measured block making, and we measured waste diverted from landfill site. So from start to present day, we calculated about 25 tons of F1 glass, fraction 1 glass, that we utilized in the block, which was recovered, which is equivalent to about 7 African elephants. Sand recovered from site and other sources as well. It was basically about 26 tons. Crusher material, the largest fraction, was about 47 tons approximately, or 14 African elephants. Sorry, my elephants, there wasn't enough space for my elephants on the screen, so I had to overlap them. We've had a lot of traffic on site. We've had a lot of traffic on site, private sector. We've had various government departments. We've had national government. There's a lot of interest in the project. To date, trained individuals working on the project able to make blocks, we had about 23 individuals. And to date, we've created 2 SMMEs on the project. Some of the challenges that we've experienced. So we're currently experiencing a huge delay in terms of getting our certification for agreement for the block to enter the commercial market. And this is a huge problem. And I can't understand how an innovative SMME in the South African landscape can wait for, what is it now? We're at 1.5 years, almost 2 years into the project, and all we've received from agreement is a file number. We were communicated with right at the beginning when we sent through the application, and we were advised that the process should take no longer than 6 months. It's 1.5, 2 years. And all we have is a project number, file number from agreement, which is very, very discouraging. This is another piece of learning in terms of how we constituted the SMME on site. When we started the project, We had some funding from a provincial government department who was paying stipends to the SMME. Now, at this time, they were simple block makers. And they expressed an interest to commercialize themselves and set up a business, basically, which was in our scope of works and something that we wanted to achieve. Now, the problem was that we were paying them a stipend, a daily stipend. And unfortunately, when we lost funding for the daily stipend, and then we started paying a commercial rate to the SMME in terms of how many blocks they made, unfortunately, the project fell down, and we basically had a lot of challenges with the SMME on site, and they eventually asked to leave the site. Design specs. This is a new innovative technology. As you can see, we had an external roofer on site. He drilled holes into the block to secure the timber and installed a roll bolt, an expanding roll bolt into the holes. Unfortunately, as he tightened the roll bolt, what happened? The blocks started splitting. So our engineer was around the back, and there was all this hullabaloo about, oh, the blocks were terrible, blah, 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 etc. So the engineer came down and said, well, hang on a second, why are you putting in an expanding roll bolt? Just put in a normal plastic plug. So we figured out a couple of solutions for some of these problems. And we had some workarounds as well. And eventually we managed to get the roof on. So thank you very much, ladies and gentlemen. That's the end of my presentation. Many thanks. If I may, just a thank you to the DSI. Thank you for their funding and support. We really appreciate that.
Thanks very much, Aubrey. Yeah, I think that was quite a mouthful from our three presenters in the room and the presenter online. I'm going to open the floor now for questions. Please just indicate who the question is addressed to if you put up your hand. Peter? Just use the mic, please, because we are live streaming and we want the people online also to hear.
My question is to Aubrey. I would love to know, how did you come to this recipe of 3 glasses of wine and 2 pints of cement? Thank you.
So it was mostly trial and error, and also our requirement was that the brick maintained its integrity. So in terms of the material substitution, we eventually we determined that substituting 67% of the actual virgin materials in the block would actually work, and we produced the brick within the tolerances that we required. And so that's how we determined that. But it was a little bit of trial and error.
Thank you. There's another question.
Thanks for your presentation. This is also for Aubrey. I'm aware that water is one of the hidden resources in building that's often not factored into design, and also the cost of buildings. How does your brick compare when you're actually mixing it to mixing, say, clay bricks, air-fired bricks, your regular cement bricks?
Gosh, interesting question. I must admit I didn't come prepared in terms of that. Yeah, look, I mean, look, I can chat with the colleagues from the project, and we can possibly come back to you. Would that work? I think one other gap that we need to plug the hole on is the carbon emissions aspect on the block. We're utilizing less cement, especially in between the courses, because we don't need cement in the courses. So in that sense, we're using less water on construction, on a square meter. But I need to come back to you on the water aspect. We still need to tie down the greenhouse gas emissions benefits on the project as well. So let's chat a bit later on and we can come back to you on that. Thank you.
Thank you. Any other hands? Yes?
My question goes to Mark. There was one picture that really stood out to me. He just breezed over it. Was the image of what might be circular economy within a residential household. I don't know if you remember that image. Could you just speak more to what happens with people and what they do within their own households on that particular picture?
Yeah, I think that was just illustrating that some of the things we were modeling could be applied within a household on a plot, on a residential plot. So, I mean, that typically, if you're composting your own food waste and then using it for the vegetables, you're using your own grey water, you're collecting rainwater, treating black water from toilets and stuff is more difficult on site. But then there's a kind of, it gets to a limit of what you can do on site. And obviously, if you're using construction waste, then it's more like, in this situation, you want to draw that from the outside in order to build on site. But I think, it was really just to start to look at the scales. There was a later slide which I didn't have time to dwell upon, but you then get the house related to your neighbors, related to the street, related to the broader neighborhood, and then the neighborhood sitting within the urban fabric. And some of the work we did on spatial transformation is also how does a neighborhood contribute to the running of the wider city, and also all these streams of consumption and waste. So that there's often these scales of seeing what you can do at some much more local scales and what you need to do at a higher scale. So if you take that Sustainability Institute project near the Spear Estate, they built a set of houses around this venue for sustainability events, and they succeeded. I think it was about 30 houses, I might be wrong, but they succeeded in having almost like a completely circular, small little neighborhood in terms of treatment of water. I don't know about consumption of water, but if I may just hook onto that, my view of urban agriculture is that sometimes I think commercial farming is more efficient, although obviously it has to be done well. And as a person who's worked on property economics as well, if your settlement is well located, you would be much better advised to build accommodation and charge rentals and produce housing stock, and then go buy your vegetables in a shop or a spaza shop than trying to grow your crops on site. But I think it's the role of the crops on site and food security in peripheral areas with very poor people is incredibly important. And so you have to look at the context, the land value, all of those trade-offs. So there's no simple one answer. It's actually what's the net benefit in any particular time and in any particular location.
Thank you. There was another hand here in front.
Thank you. My question, I have at least 3 questions. My first question will go to Mr. Mark. Yes. In terms of, but first I loved how you integrated challenges into solutions, like in terms of all challenges and all solutions in terms of waste and how to reuse it. I really liked it. It dovetails our missions. First question will be like, in terms of grey waters, I'm asking this question because we also failed. we also failed in terms of reusing grey waters because we wanted to use the grey waters in our mesophilic biodigesters. In that sense, we wanted to mix the solid crushed waste that is a feedstock to grey waters. But the challenges was in terms of measuring the contamination of water, categorizing which water is relevant to use in this sense. So in your side, do you have any tools to measure contaminations? And then which water, grey waters, were you promoting or were you encouraging individuals to use sink, kitchen waste, grey waters, or which waters? And then my second question will be to the lady. I didn't catch your name, but then my second
Tahira.
question will, yes. And then in terms of circular economy, we depend more into funding because the circular economy speaks to different reuse of waste, recycling of waste. And then one of the prominent recycling that is sustainable is recycling of buyback materials like your glass, your tins, your plastic, and everything. But when it comes to recycling or reusing biodegradable waste, there you can generate any profit. Recycling or reusing of construction waste, there you can produce or because this kind of waste, they are the prominent solutions to at least generate biogas, generate biofertilizer, and also solve social critical issues in terms of infrastructure and other things. But there you can't produce or generate any profit. And then my question is that, is there a model in terms of sustaining the funding after the period of funding? The SME can, the SMEs or the innovators, can they be able to make sure that they have the sustainability after the funding? Because we can't go back asking for funding to sustain our solutions. That's where my question lies in terms of circular economy, in terms of sustainability. And Mr. Andrew, in terms of the bricks, if maybe now you are certified and then the demand is high, do you have the model that is there to at least finish or allow you to utilize or harness a lot of recyclable materials as you are processing, as you are processing a lot of recyclable materials to sustain the demand of the market? Thank you. That's all my questions.
Thank you, and that's going to be the last question because answers now stand between us and lunch. Mark, will you take it first, and then we will hand to Tahira and then to Aubrey.
Okay, thank you. I'll have to follow up with you on the sort of contaminant side because I'm not being a water expert as such. We have to look at those kind of tests. I think just sort of simply speaking, the safer ones are rainwater to garden vegetables, rainwater to flush toilets. And so the modeling that we did included those kind of options as well. Then reuse of grey water, obviously that has to be done much more carefully. I saw a project, I think it was in Sweden, with a cooperative housing, and all the grey water went into a tank in the middle, and they had tilapia fish there. They would eat the fish. Then somebody used the wrong detergent on a day when they were washing the dishes, and then the fish died. So you've got to go into it as a system and decide what you want to achieve, both as a household, then as a community. I think as you said, the contaminants is a big issue. So I think that is behind some of that reticence that people have.
Thank you, Tahira.
Thanks for your question. I hope I understood it properly. Was it referring to sort of, is there a model or can a model be created that takes into account material inputs, but also economics, such that the project is actually sustainable, basically, financially sustainable in the long run? I can't say I've come across one or that I've personally used one. But my best guess would be that it would be some sort of hybrid model, so where it would be a material flow analysis that shows the flow of whatever material you're looking at, combined with some sort of economics, so perhaps a life cycle costing model. And obviously, you can create any model you want, but your model is only as good as the data you put in. And it comes down to data availability. I didn't touch on it in this particular presentation, but that's always a challenge. And perhaps lastly, I just wanted to say that it's also, a couple of sort of challenges, but also things to look out for is in terms of your quality of your feedstock, and then whether your recycled material, whether there's a market application for it, and whether it can compete with virgin material. I hope that answers your question. Thanks.
Thanks, Tahira. Aubrey?
So the last question was very interesting, because currently in our landscape or in our ecosystem that we're developing the block, the engineer who owns the background IP on the machine, he wants to execute the project in terms of a sale of the machine. Now, we've recently made him aware that there are other opportunities that he could consider. For example, a leasing scenario. But it's going to depend on how and a lot of these projects depend on how flexible the implementers are and the project proponents are. It's going to depend on how flexible he is to deploy the correct model into the economy to grow the uptake of that machine and that product. In addition to that, we've got to be very careful in terms of the SMME that we're selecting, and we've got to be very careful in terms of setting them up for expectation. So in terms of your risk, if an SMME is already constituted and is already playing in the construction sector, they will understand the risks with regards to going into that sector and simply just tweaking a new technology and deploying a new technology. But if you have individuals who don't initially have a business sense, your risk goes up. Your risk goes up. So it's very important. You can mitigate risk with training. You can mitigate risk with interaction and hand-holding. But how much hand-holding are you going to provide to an entrepreneur? You've got to have an entrepreneur has to have the drive in him to take the project from here to there. He's got to have the drive to take the project from level 1 to level 2. So I know I'm not answering your question 100%, but I'm giving you as much info as I think it's important to be aware of those factors.
Thank you very much, Aubrey. And thank you very much to our panel. Shall we give them another round of applause? And then you're invited to lunch. Thank you very much for attending the session. Your presence is much appreciated. Thank you. Picture time.